All right, in this video, this is going to be me, Noah, and Jeremy and others trying to explain to Bob the science guy spherical geometry because he has a total misunderstanding or lack of understanding of spherical geometry. And I think this should be eye opening. But first, I'm going to play a clip from a video I made a year or two ago talking about due east and due west, how it's 90-degree angles from north, and how 90-degree angles form geodesics or great circles. Or if you draw a plus sign on the surface of a sphere, you're going to split the ball in half both ways, or forming a meridian and an equator. But I think you're going to like this because it points out and makes it crystal clear their lack of understanding of spherical geometry. And it's even funnier because Bob tries to act like he knows and we're wrong, and Negator tries reading axioms that he obviously doesn't understand. Just give it a listen. Shouldn't have to be doing this, so please listen carefully. What is due east and due west? No matter where you're at on Earth, except the North and South Pole, you have a due east and a due west point on your horizon. That point marks the intersection of your horizon with the celestial equator. So on equinox, the sun rises due east for everybody, okay, which is a geodesic, okay? Now look, a geodesic is also a great circle. Great circles are straight lines in spherical geometry, okay? I shouldn't be having to go over this, but this is what it takes. A geodesic is a great circle or a straight line.
Say it again one more time.
Think about, okay, right angles are congruent. Think about the intersection of the equator with any longitude. These two geodesics will meet at a right angle.
By geodesics, they mean great circle routes, right?
I don't know. Doesn't matter.
Yeah,
It doesn't matter.
Equator
It absolutely
and the
matters.
longitude.
Jeremy.
Right.
Hold on.
It
I'll tell you why
says-
it matters.
Holy fuck.
It says equator and longitude. If you want to define them as great circle routes, that's fine.
But they're not any great circle routes because you can have any great circle, two great circles meeting at any angle on the surface of a sphere.
And they're all going to split the globe in half with an equator, no matter where you draw the right angle. How do y'all not understand this? This is
Not at the equator, no.
Only at the equator.
No.
Dipshit.
And if you guys read that document, it then says, how do we interpret the first four axioms of this sphere? So we're about to interpret that fourth axiom. All right angles are congruent. If you look down at that same document, it says angles. Right angles are congruent. Think about the intersection of the equator with any longitude. These two geodesics will meet at a right angle.
Very good.
What else do you
That's
want?
the one I said I'd use. That's the one I said I'd use. Right there. So okay, so you agree that every right angle is going to form an equator and a meridian on the surface of a ball, right?
Brian, why does it say these two geodesics will meet at a right angle?
That means every right angle would form a equator and a meridian, right? No matter where we drew a right angle on a sphere, if we extended them, it'd be two great circles, correct?
Hold on. Man. Christ, you said great circle routes meet at 90 degrees.
No, he didn't.
He's a geodesic. What?
The geodesic.
Is that a great circle route?
No, he didn't.
Hilarious. So even after we explained it and Negator read it to him, he still denies that great circles or geodesics meet at right angles. It's like talking to a mule.
Well, you divide that circumference by the radius or by the diameter, and you have pi.
Yeah,
There you go.
we're talking about only on the surface, though.
Yeah, they're talking about if you drew a circle on the surface of a sphere.
Yeah.
And they're saying that you should use a radius value that's not derived from the shortest point between that circle, because on a sphere. So Bob literally just told us the formula on how to get the area of a circle. I mean, you can't make this shit up, Earth
people.
That would go through Earth. They're saying
Yeah, it
the
would be a
diameter would they're not saying you wouldn't use the chord. You would slope across the surface of Earth, and that would be a larger diameter than what would produce the circumference of.
Yeah, you can't use a chord. You can't use a chord in spherical geometry.
Sure you can. Why can't
No, you
you use
can't.
a chord in spherical
Beach.
geometry?
Oh, you
Beach,
can.
can you?
It's just
Beach, can you use a
definitional.
chord in spherical?
It's just you cannot. It's just definitional because spherical geometry is a geometry restricted just to the surface of the sphere.
Talk to him.
Yeah.
All right,
Yeah.
Bob.
Okay.
You good, Bob?
Exit. You can't exit the surface of the sphere, go through the interior of the sphere, and then hit the other end of the surface, because then you would not be in the actual surface of the spherical geometry coordinate system. So you can't do that.
Ratio.
Mm.
So what is a circle on the surface of a sphere? Is it not a circle?
It's a circle.
Yeah, it's a circle.
Smaller circle.
Bob, you're talking about measuring area, Bob. So you can go all the way around the sphere and take a right turn, and so you can't have nothing lower than 2 and nothing bigger than 3.14159, because you just basically made a right angle. And I can use number easily debunk the model, but I was sitting back for 5 minutes, but I can easily use what Jesse just read out to debunk the globe model.
Well, I can use spherical geometry.
It's like misleading or lies.
Well, I can use spherical geometry on a basketball, right? And if I draw a circle with a water glass on a basketball, I can use spherical geometry to define the area of that circle, right?
Dude, it literally, Brian, spherical geometry exists within Euclidean geometry. It's a transform.
Exactly. That's what I'm trying to teach them, that if you're measuring area, you can't use a chord line on the surface of a sphere. So if you just sit back and listen, Bob, we'll teach you spherical geometry.
You're not going to teach me anything, Brian.
Yeah.
To be fair, Bob, I think you did learn something just now about spherical geometry, that you can't have a chord. So
Yeah, Bob fucking thought you could just go into the interior and do whatever you want.
Okay.
What's the radius? What's the diameter of a sphere?
When the fucking coordinate system is 2-dimensional. God
Yeah, but
fucking
what's
damn it. What is wrong with you? You're fucking
Noah.
a grown man.
Stop ruining the
You're a grown
conversation,
fucking
Noah.
man. Stop yelling,
Come on,
stop
come on, come on.
yelling over me when I'm
more.
We're saying that the formula to get the circumference from that radius, you use the radius to get the circumference. That formula might be different.
Oh, what's the formula for getting pi on a sphere then?
I don't know.
Why would it be any different than the circumference divided by the diameter?
Because now you have a pi and non-constant pi.
Why is it non-constant?
You would come up with a different number.
Not the area.
Well, just go ahead.
More area.
Does pi have to do with the area, or can it be measured? Can it be determined from the diameter?
Is directly calculated.
Does pi have to do with the area? But they're not any great circle routes, because you can have any great circle, 2 great circles meeting at any angle on the surface of a sphere.
So after all that, that's the statement he makes, that you can have 2 great circles meet at any angle on a surface of a sphere. Dude, Negator just read it, literally just corrected him. The great circles meet at right angles, Bob. I know you don't get it, bro, but it's crystal clear. It's your model that we're trying to teach you. This is why they don't understand the equinox, sunrise, and sunset destroys their model, because they don't understand that every person along a meridian is looking along a geodesic. They're all converging. This is what we deal with over at Earth Awakenings. They rather make a fool of themselves than admit they learned something from us. But thanks for watching. Figure y'all enjoy.